Lotus Academy of Diet and Fitness.
Chapter 8. Nutritional Bioavailability. Nutrient interactions in nutritional bioavailability. Nutrient interactions affect how much of a nutrient the body can use after it's consumed, known as nutritional bioavailability. Several factors and interactions influence how well nutrients are absorbed and utilized. Enhancing or inhibiting factors. Certain nutrients can help the body absorb others better, like vitamin C improving the absorption of plant-based iron. Conversely, substances in tea and coffee can hinder iron absorption. Vitamin D and calcium. Vitamin D is essential for absorbing calcium from the intestine. Without enough vitamin D, the body might not absorb calcium well, increasing the risk of calcium deficiencies. Phytates and minerals. Phytates found in plant-based foods can bind to minerals like iron, zinc, and calcium, making them harder to absorb. Soaking, fermenting, or sprouting can reduce phytate levels and improve mineral absorption from plant foods. Fat-soluble vitamins. Vitamins A, D, E, and K are fat-soluble, meaning they require dietary fat for proper absorption. Consuming these vitamins with a source of healthy dietary fat can improve their bioavailability. Nutrient competition. Some nutrients may compete for absorption sites in the intestines, affecting each other's uptake. For instance, high levels of zinc intake can inhibit copper absorption, and vice versa. Gut health and microbiota. A healthy gastrointestinal tract and a balanced gut microbiome are crucial for optimal nutrient absorption. A well-maintained gut lining and diverse gut bacteria aid in the efficient absorption and utilization of nutrients. Protein and amino acids. Protein-rich meals can enhance the absorption of certain minerals like iron and zinc. Additionally, the presence of specific amino acids may influence the absorption of other amino acids. Dietary fiber. Fiber, while essential for gut health, can also bind to certain minerals, reducing their bioavailability. However, soluble fiber can have a beneficial impact on cholesterol metabolism and may slow glucose absorption. Vitamin B12 and intrinsic factor. Vitamin B12, found primarily in animal products, requires the presence of intrinsic factor, a glycoprotein secreted in the stomach, for efficient absorption in the small intestine. Alcohol and nutrient absorption. Excessive alcohol consumption can impair nutrient absorption, particularly with respect to vitamins like thiamine, folate, and vitamin D. Food matrix in nutritional bioavailability. The food matrix, or the structure of a food, affects how nutrients are absorbed and used by the body. It influences how nutrients are released during digestion, how they interact with other components in the gut, and how they are absorbed into the bloodstream. Here are some key aspects of the food matrix in relation to nutritional bioavailability. Physical structure. The physical structure of food impacts how nutrients are protected or encapsulated. Nutrients inside cell walls of plant-based foods may be harder to access during digestion, needing cooking or processing to release them. Nutrient encapsulation. Some nutrients may be encapsulated within certain food components, such as proteins, fibers, or lipids. These encapsulations can affect nutrient release during digestion and influence their bioavailability. Interaction with other food components. Certain components in food can interact with nutrients, affecting their absorption. For example, fibers or phytates in plant foods can bind to minerals, decreasing their absorption. Presence of co-nutrients. Co-nutrients are different nutrients found together in a food. Some co-nutrients can boost or hinder the absorption of specific nutrients. For instance, vitamin C can improve iron absorption from plant foods. Food processing and preparation. Food processing techniques like cooking or soaking can change how nutrients are available for absorption. Cooking can break down barriers in food, but it can also cause nutrient loss. Cooking methods. Boiling vegetables can make water-soluble vitamins dissolve into the water, reducing their amount in the food. Anti-nutrients. Some foods have anti-nutrients that can block nutrient absorption. Phytates in grains and legumes, for example, can decrease the absorption of minerals such as iron and zinc. Nutrient stability. The stability of nutrients during storage, processing, and cooking can impact their bioavailability. certain nutrients may degrade or be destroyed, diminishing their availability in the food. Food particle size. The particle size of the food can affect its transit time through the digestive system and impact nutrient absorption. Finely ground foods may have a larger surface area, potentially leading to faster absorption of nutrients. Anti-nutritional factors in nutritional bioavailability. Anti-nutritional factors are natural compounds in some foods that disrupt nutrient absorption or utilization. They're termed anti-nutritional, as they lower the food's nutritional value by hindering essential nutrient absorption or efficacy. Some common anti-nutritional factors include phytates, phytic acid. Phytates, present in grains, legumes, nuts, and seeds, can attach to minerals like iron, zinc, calcium, and magnesium. This binding reduces mineral absorption in the gut, potentially causing deficiencies, particularly in plant-rich diets with high phytate levels. Oxalates. Oxalates, found in spinach, rhubarb, and some nuts, can bind with minerals like calcium, forming insoluble complexes that hinder absorption. Overeating oxalate-rich foods may increase the risk of kidney stone development. Tannins. Tannins, present in tea, coffee, wine, and some fruits, can hinder the absorption of minerals like iron, especially from non-heme, plant-based sources. Lectins. Lectins, proteins found in legumes and grains, can potentially disrupt nutrient absorption and cause digestive issues in some people. Protease inhibitors. Compounds present in certain plant foods, such as legumes, can hinder the action of digestive enzymes, potentially impeding the digestion and absorption of proteins. Goitrogens. Goitrogens are substances found in cruciferous vegetables, such as broccoli and cabbage. They can disrupt the uptake of iodine by the thyroid gland, which may contribute to the development of goiter or thyroid issues. Enzyme inhibitors. Some foods, especially raw legumes and seeds, contain enzyme inhibitors that interfere with the activity of digestive enzymes, affecting nutrient absorption and digestion. Saponins. Found in legumes, some grains, and certain vegetables, saponins can disrupt cell membranes and potentially inhibit nutrient absorption. It's essential to understand that foods containing anti-nutritional factors aren't necessarily unhealthy or off-limits. These compounds often have health benefits and can be part of a balanced diet. Plus, techniques like cooking, soaking, and fermenting can decrease anti-nutrient levels, making nutrients easier to absorb. Individual factors in nutritional bioavailability. Apart from the composition of food and anti-nutrient content, individual factors also affect nutrient absorption. These include a person's health, genetics, and bodily functions. These factors determine how well the body can absorb and use nutrients from food. Some important individual factors in nutritional bioavailability include age. Age can affect nutrient absorption and metabolism. For example, as people age, their ability to produce certain digestive enzymes may decrease, affecting nutrient digestion and absorption. Gastrointestinal health. A healthy gastrointestinal tract is essential for proper nutrient absorption. Conditions like celiac disease and inflammatory bowel disease can hinder this process, potentially causing nutrient deficiencies. Gut microbiota. The composition and activity of the gut microbiota can influence nutrient bioavailability. Gut bacteria can metabolize certain compounds, producing metabolites that may affect nutrient absorption and utilization. Nutrient interactions. Individual nutrient status can influence how well other nutrients are absorbed and utilized. For example, deficiencies in certain vitamins or minerals can affect the absorption of other nutrients. Medications. Some medications can interfere with nutrient absorption or metabolism. For instance, certain antibiotics may reduce the absorption of certain vitamins. Genetics. Genetic variations can influence how individuals metabolize and utilize nutrients. For example, some people may have genetic variations that affect their ability to absorb certain vitamins or minerals. Nutrient status. The body's existing nutrient levels can impact how well it absorbs and utilizes additional nutrients. Deficiencies or excesses of certain nutrients can affect their absorption and metabolism. Pregnancy and lactation. During pregnancy and lactation, nutrient requirements increase, and certain nutrients may be absorbed more efficiently to support the needs of the developing fetus or breastfed baby. Disease conditions. Certain medical conditions, such as liver disease or kidney disease, can alter nutrient metabolism and utilization, affecting bioavailability. Alcohol and tobacco use. Excessive alcohol consumption and tobacco use can impair nutrient absorption and utilization, leading to deficiencies. Body composition and weight. Body composition, including factors like body fat percentage and lean body mass, can influence nutrient distribution and metabolism. Nutrient form in nutritional bioavailability. The way nutrients are structured chemically can affect how well the body absorbs and uses them. Factors like solubility and stability can vary between different forms of nutrients, influencing their absorption and availability for the body's needs. Some key aspects of nutrient form and their influence on nutritional bioavailability include heme versus non-heme iron. Iron comes in two forms: heme iron, which is in animal-based foods like meat, and non-heme iron, found in plant-based foods such as grains and vegetables. Heme iron is usually more easily absorbed by the body compared to non-heme iron. Retinol versus carotenoids. Vitamin A. Vitamin A is available as retinol from animal-based foods or as carotenoids like beta-carotene from plant-based sources. The body absorbs and uses retinol more efficiently than carotenoids, although some carotenoids can be converted into retinol in the body. Methylcobalamin versus cyanocobalamin. Vitamin B12. Vitamin B12 is usually in supplements as cyanocobalamin, but the body needs to change it into the active form, methylcobalamin, to use it. Taking methylcobalamin directly can help the body use it better, especially for people with certain genetic differences that affect B12 absorption. Folate versus folic acid. Vitamin B9. Folate is the natural form of vitamin B9 in foods, while folic acid is the synthetic form in supplements and fortified foods. Folate is usually easier for the body to use than folic acid, especially for people with specific genetic differences affecting folic acid processing. D2 versus D3. Vitamin D. Vitamin D comes in two forms: D2 from plants and D3 from animals and sunlight. D3 is more powerful and easier for the body to use compared to D2. Forms of minerals. Minerals can take on various forms like elemental, chelated, or salt forms. Chelated minerals, bonded to organic molecules, might be easier for the body to absorb compared to other forms. Bioactive versus inactive forms. Certain nutrients come in active and inactive forms, with only the active form being usable by the body. For example, vitamin B6's active form is pyridoxal 5-waror phosphate, PLP, while pyridoxine is an inactive precursor that must convert to PLP to be useful. Omega-3 fatty acids. Omega-3 fatty acids from fish and seafood come as eicosapentaenoic acid, EPA, and docosahexaenoic acid, DHA, which the body absorbs and uses more efficiently than plant-based omega-3 alpha-linolenic acid, ALA. Processing and cooking in nutritional bioavailability. Food processing and cooking can impact the availability of nutrients in both good and bad ways. How we prepare food can affect how well our bodies absorb and use the nutrients it contains. Let's explore some of the effects of processing and cooking on nutritional bioavailability. Enhanced nutrient bioavailability. Cooking breaks down plant cell walls, improving nutrient access. For instance, heat boosts beta-carotene in carrots and lycopene in tomatoes. Inactivation of anti-nutritional factors. Soaking, fermenting, and sprouting reduce anti-nutrients like phytates and lectins in foods. This boosts mineral and protein absorption from plant-based diets. Improved protein digestibility. Cooking denatures proteins and makes them more accessible for digestive enzymes, improving protein digestibility and absorption. Increased mineral bioavailability. Cooking can break down mineral-binding compounds like oxalates and tannins, increasing the bioavailability of minerals like calcium, iron, and zinc. Increased energy availability. Cooking increases the availability of energy from carbohydrates and fats by breaking down complex carbohydrates and lipids into simpler forms that are easier to absorb. Loss of heat-sensitive nutrients. Some nutrients, such as vitamin C and certain B vitamins, are heat-sensitive and can be degraded during cooking, especially with prolonged high-heat cooking methods. Leaching of water-soluble nutrients. Boiling and blanching can cause water-soluble nutrients like vitamins B and C to leach into the cooking water, resulting in nutrient losses. Formation of harmful compounds. High-heat cooking like frying or grilling can create harmful substances like acrylamide and PAHs. Excessive intake may pose health risks. Preservation of nutrient-rich foods. Proper food processing techniques, such as canning and freezing, can preserve the nutrient content of foods for longer periods, ensuring that they remain available and accessible throughout the year. Balancing food safety and nutrient preservation is crucial. Methods like gentle heating and minimal water usage help retain nutrients. Combining cooked and raw foods in the diet provides diverse nutrients for better absorption.